Hi everybody to our final presentation of Scan2Cap. So our project was supervised by Dave and I present you today with my teammate Felix. I'm Nicolas. Hi. So as the name Scan2Cap indicates, our goal is that we have a scanned 3D scene such as the point cloud below and a bounding box of an object, and we want to generate a meaningful description that sets the object in a spatial and a semantic context to its environment. We are motivated by actually providing a good basis for dense captioning. This is to generate a single description of a whole scene with a single shot, but this is beyond the scope of our project. With our work, one could stack all obtained descriptions for all objects. So to wrap this up, this is our contribution. First, we are pioneering the task of captioning on point clouds to the best of our knowledge. And second, to achieve this, we want to test and exploit different components set up in our pipeline. Finally, the project is a good basis for end-to-end dense captioning. So how do we achieve these goals? Herefore, we have set up a pipeline or 3 pipelines based on each other. Let's start with our baseline pipeline. As an input, we get a point cloud and a target bounding box. This goes to the feature extracting part using a PointNet++ extractor. This is then fed into our iterative captioning module, which basically consists of an LSTM and a word classifier, giving us the word-by-word predictions. In our improved architecture, we use a ModeNet object detector to give us local object-related features. These are concatenated with global features obtained from PointNet++. During the training of that improved architecture, we found out that actually network returns many proposals that are far away or not important. We have to filter them out to get better results. In our most sophisticated version, we use visual attention as described in the paper Show, Attend, and Tell. Here, the word proposals are directly fed into the attention module and also the hidden state of the LSTM. All right, so that's so far for the theoretical part. Let's jump to the results.
Yeah, to evaluate the performance of our models, we use a set of 4 commonly used NLP metrics, namely the Bleu-4, Meteor, Rouge, and CIDR scores. And we can see that with every model iteration, we're able to improve the performance of our model by a slight margin, and our attention model performs the best for 3 out of the 4 metrics. For the Bleu-4 score, it's basically on par with our improved architecture. And this performance improvement is also visible in the predicted captions itself. So, for example, right here, we have a hotel room and we're interested in this black office chair. The ground truth caption would say, there is a black chair. It is next to a cabinet on the side of the room. Now our baseline architecture predicts this is a black chair. It is to the left of the table. So a reasonable description, but still fairly generic. Our improved architecture now takes into account the objects within those blue bounding boxes, and it says this is a black chair. It is to the left of the desk. So a little more specific, but the best caption is predicted by our attention model, and it says this is a black chair. It is at the end of the bed. So very context specific, and also for the bed token, we can clearly see the attention focus on the actual bed object. This attention mechanism can be observed in many examples. For instance, right here, where we are interested in this white radiator on the wall. The ground truth caption says the radiator on the wall, the radiator is next to the toilet. And our attention model predicts this is a white radiator. It is to the right of the toilet. And again, for the toilet token, we have our attention focus on the toilet object. In this a little more complex example, we have a very detailed ground truth caption that says the open kitchen cabinet is directly above the sink and the water container. The open kitchen cabinet is a brown box with one side hanging out. And even though this is a fairly challenging example, our network predicts this is a white kitchen cabinet. It is above the sink. And again, the correct attention focus for the sink token on the actual sink. Now, to give you some sort of outlook about what could be done with our technology in the future, we replaced the ground truth bounding box input with a VoteNet bounding box input. And we can see that even though the bounding boxes are maybe a little lower quality, our network can still predict very nice captions. So thank you very much for your attention, and we're looking forward to the Q&A stream on Friday.